In your textbook, you'll see tables that also indicate the chronic adaptations that occur with resistance training. And so you can look at those on your own. But as far as the neurological changes that do occur, most of the early changes, the initial strength gains that we see, are not due to hypertrophy or enlargement of the muscle. They're due mostly due to neurological recruitment or motor unit recruitment. And so the body is better at recruiting those larger motor units, as well as the motor units that are required to make us move more efficiently. There is also a decrease in the co-contraction, which is the contraction of the agonist and the antagonist. The agonist is the prime mover, but at the same time, there's some contraction of the antagonist or the opposing muscle group. And so, when these initial strength gains, we see a decrease in that co-contraction. So only the agonist is stimulated, which allows us to produce greater torque or rotation around that axis. And so we see that untrained subjects now have a greater ability to activate these larger motor units to produce force. And we can also as well see chronically an adaptation where they have an increased ability to increase the rate coding, or the stimulus is the frequency of the stimulus can be shorter and faster to stimulate the muscle to increase the muscle force. And we also see an increase in ability to stimulate the motor neurons. But in the long term, the main adaptation that we see in the skeletal muscle is muscle hypertrophy. And so this is the actual increase in the cross section of the muscle, or the size of the muscle, and so it can produce a greater amount of force. And hypertrophy is due to synthesizing muscular protein, the actin and myosin, the contractile proteins. So it makes the muscle fiber larger and increases the ability to create force. And it occurs in both type 1 and type 2, or slow twitch and fast twitch, but it occurs more so with resistance training in the fast twitch muscles. Hyperplasia is increasing the number of muscle fibers. It has not been well documented or demonstrated to occur in humans. The primary mechanism is believed to be hypertrophy, which is the size of the muscle fiber, whereas hyperplasia is the number of muscle fibers. And there again, there's not strong research showing that that occurs. And so we've had this before as well, that when we perform in our training mode eccentric contractions, that's going to stimulate more hypertrophy, more of the protein synthesis. Other type of hypertrophy occurs with the cytoskeleton, and that is what gives the shell its shape. And so this will affect the ability to transfer the force that the muscle generates to the connective tissue. So the endomysium, the paramysium, it's greater in transmitting that force that's produced when the sarcomeres shorten. As far as bone and the benefits of resistance training, it's believed to decrease the risk of osteoporosis. Osteoporosis is when we lose minerals or calcium is extracted from the bone, and it weakens the bone. It makes the bone prone to just breaking, even with weight bearing. And it's believed that the more bone density that we establish earlier in our youth and through our adult years, it's going to decrease the risk of osteoporosis, because postmenopausal women especially, they lose bone density. So our bones are very responsive to demands that are put on them, and it can be like compression, the force that comes down on the bone when we jump. It can be twisting action, or it can be bending action of the bone. These will stimulate the bone to lay down more bone matrix and make the bones more dense and stronger. We see changes in the tendons and the ligaments. Tendons are, if you recall, what connect the muscle to the bone, and a ligament is what connects bone to bone or maintains the joint. And we see an increase in the tendon size, but also the tendon stiffness, which allows us to transfer more force to the tendon. Metabolic changes that are seen with a resistance training there's some debate. Some studies show an increase in storage of ATP and creatine phosphate, so that's going to affect your phosphagen system, and other studies don't demonstrate this. And so, as well as the increased enzymes for anaerobic energy production. It might be related to the type of training, the muscles trained, genetic differences. So in some studies we see these changes, others we don't, but it still needs to be further researched to find out, what is the actual case. And then endocrine changes just show that with chronic adaptation, doing resistance training for longer duration, we do see elevations in testosterone, and so that would promote more protein synthesis and muscle hypertrophy. Cardiorespiratory changes. When you run, we do see increases in VO2 max. That's the amount of oxygen your body can consume and use, but we don't see an increase in your VO2 max or your cardiovascular function with resistance training. But we can see an effect on our oxygen consumption by muscles working more efficiently, that it uses the oxygen that it consumes more efficiently. We have stronger muscle contractions. So resistance training can supplement cardiovascular types of exercise. We don't see the increased ability to produce energy oxidatively in the muscle. So there's not an increase in enzymes, there's not an increase in mitochondria where oxidative energy production occurs. There is not an increase in myoglobin, and myoglobin is what transports oxygen into the mitochondria. The thing that we do see is an increase in capillaries that supply the muscle. But we also often talk about muscle to capillary ratio. That's the cross-sectional area of the muscle in comparison relative to the amount of capillaries that we have. And that ratio remains the same because at the same time we're increasing the number of capillaries to that muscle, we're also increasing the cross-sectional area, so that the ratio doesn't really change. Body composition changes. We have two types of tissue. We have what we call fat-free mass and fat mass. So fat-free mass is all type of tissue and that are not fat. And so as we see increased density of bones, as we see hypertrophy of muscle, we're going to see an increase in our fat-free mass. So even if our amount of fat on our body doesn't change, our percent body fat is going to decrease just by that we're increasing our fat-free mass with resistance training. And so as far as decreasing the amount of fat that our body has, we can consume more calories in a resistance training program, because the more intense workout that we do, the more sets, the more reps, longer duration, we're going to consume more calories, and that's going to help decrease the amount of fat that we have. There's also, we can increase our metabolism by that muscle is more metabolically active. It uses more calories as we increase our muscle mass. I will say, though, that there is some discrepancy in what research shows with this. And also the potential with a very intense, more vigorous workout to increase our EPOC or excess post-oxygen consumption, and that can cause us to have an elevated metabolism post-exercise. And